Welcome to this video tutorial. In this video, I'm going to show you how to perform transient calculations using ELEK cable HV software. The software has the following capabilities. Transient temperature response of a cable can be calculated for a user-specified load factor for 24 hours, as recommended in IEC 60853. Emergency current ratings for user-specified load factor with percentage preloaded current. Cyclic ratings using the IEC 60853 method or the Néa-McGrath method. The effective change in conductor resistance with temperature is incorporated in the calculations. The definition of emergency rating is the permissible short-term rating of a cable already loaded and at a steady state, considering the thermal capacitances and the thermal resistances of an installed cable system. The definition of cyclic rating is the maximum current of a cable when the load is varied in a sequence of steps that are repeated cyclically. The cyclic rating differs for different sequences and different cyclic periods. Both emergency and cyclic ratings deal with time-varying loads. The methods of calculating emergency and cyclic ratings of cables used in the software are based on the IEC standards. According to the standards, emergency ratings are applicable both for cables installed in air and buried cables, direct, in backfill or in ducts, whereas cyclic ratings only apply for buried cables. The standard deals with time-varying loading by representing the physical cable system and its surroundings using a thermal ladder network of thermal resistances in series and capacitances in parallel, where heat flow within the cable emanates radially to the outside of the cable and onto the environment. The figure shows the thermal ladder network model for a multicore high-voltage cable. A fundamental part of the transient calculations is to determine the transient temperature response for the cable. The transient temperature response is the response to a step of sustained rated load current. The transient calculations along with values from steady-state rating calculations are both used as inputs to the emergency and cyclic rating calculations. Note that this plot displays the change in conductor temperature above ambient due to a step in load current. It does not show the actual temperature attained during the emergency or cyclic loading. Let's learn how to calculate the emergency current rating of a cable. First, select the cable model and set up the installation conditions to calculate the steady-state current rating, which is 470 amperes. Next, open the transient rating module and you will notice the title of the window confirms whether the cables are in air or buried cables, which affects the calculations. Select the circuit to study from the drop-down. Note that for emergency and cyclic rating calculations, the cable circuits are assumed to be in isolation. Under the emergency rating inputs, set the load factor and the transient time. You should set the transient time to be longer than the emergency rating duration, but it has a maximum of 24 hours as per the IEC standard. Set the maximum emergency temperature, which is the allowable conductor temperature attainable during the emergency event. Press Calculate. From the emergency rating plot, we can zoom and we can find the exact 12-hour emergency rating to be 617.9 amperes. The meaning of this rating is that during an emergency event the cables can be loaded with this current for up to 12 hours without exceeding 110 degrees. Under the Advanced tab, we can set the current prior to emergency loading from 100% to 50% and then recalculate. In this case, the emergency rating for 12 hours goes up to 807 amperes. Emergency rating will increase for a shorter emergency time, and if the loading prior to the emergency is lower. Let's learn how to calculate the cyclic rating of a cable. There are two separate methods for calculating the cyclic rating, the IEC method and the Néa-McGrath method. The IEC calculation method for cyclic ratings requires the user to input an hourly load profile for a minimum of 6 hours. Typically, the custom load profile data will cover a 24-hour period, but it can be for longer than 24 hours or a shorter time period. The user can manually specify the loaded current for each hour or import a custom load profile as a CSV file. A current value can be specified at a time or for a duration. The duration setting is easier to use for longer periods such as over hundreds or thousands of hours of load data. In this example, we will calculate the cyclic rating for a custom 24-hour load profile using the IEC method. After pressing Calculate, we can switch to the cyclic rating table to view the calculated loss load plot along with the cyclic rating M factor and permissible peak of load current value. The peak load current value is calculated by multiplying the continuous rating with the M factor. The ELEK graph method is available and uses the load factor value under the emergency rating inputs. In this example, we will set the load factor equal to 0.6, which is a typical load factor used for calculating the cyclic rating for cables connected to solar PV power plants. After pressing Calculate and switching the view to the Cyclic Loading tab, we can see the updated cyclic rating factor and permissible peak of load current value. A detailed report is generated by pressing the Report button. There are two main sections to the report: the inputs and the results. The input section contains the name of the circuit and its steady-state rating. The emergency and cyclic rating calculation inputs are also shown. The results section includes the calculated transient response values along with the transient temperature response plot. There is also the emergency and cyclic rating results and plots. Thank you for watching. If you enjoyed this tutorial, please check out our other tutorials for ELEK cable HV software.